If you're inventing a new chemical and you want to put it in the food because it has some miracle property, you need to test it on mice and rats first. That's how it's done.
But here in Canada, independently studying this effect on mice and rats is not being conducted under control of the Canadian Food Health Safety or something.
It has not been tested in the USA or in Canada because of a decision by the government agencies that engineered plants are no different than the non-engineered plant. It's the concept of substantial equivalence. So basically the concept of substantial equivalence says that the engineered plants are absolutely not different in any way from the plants that were used to be engineered.
So if they are not different in any way, why grant a patent?
That is a very good question. When you go to the patent office, you are asked to prove that your invention is completely different from anything else that existed before. So that if you have engineered a plant, you are asked to show that it is completely different than the plant that was not engineered. Otherwise you don't get a patent.
So there's some contradiction here, isn't it?
There is an incredible contradiction. It's a play on words, I don't know how to find the word to define it. It's an amazing, it's not a scientific problem really, it's a political problem. I mean, the US government and the US government agencies have decided in their wisdom that there's plenty of money to be made, and the biotech industry is very happy that their political influence has come to that, and so this is the system we have now. There is substantial equivalence and there is a great deal of patenting, and the two come together, and yet it's a flagrant contradiction.
Wonderful. Thierry, do you have anything else for the listeners to advise them what they might want to do with their own health and food that they're listening?
I don't speak to that. No, I try to stay to the science, and obviously with everything I've just said today, I think it's pretty obvious that people should be concerned.
Those who are not...
If I want to say something, it's not about how to protect yourself, it's about how to make your voice heard. Because right now, and for the last several years, every time there's a survey, every time there's a poll, 60 to 90% of people say, yes, absolutely, I am concerned about genetic engineering, I think it should be tested.
How about labeling? Why isn't it even being labeled since there's...
Because if every country that has introduced labeling, there is no GM food sold. People don't want it.
I understand, but isn't it's a people's right to be able to know what they're eating?
If the foods are labeled, then people will have a choice, and they will not buy it.
Shouldn't it be their right? Shouldn't it be their right to know?
You can answer that question.
So it's a basic rights issue too, I suppose, at least from my point of view.
Again, it has to do with the concept of substantial equivalence. Why should you worry about it? It's the same. There's nothing to worry about. But every time, if you want to bring in a food that has... If you want to bring a food, a novel food that's a little bit different from a regular food. If you have a new carrot, you're a plant breeder and you plant a new carrot, the FDA will be very interested to know that there is now more in that new carrot of a particular molecule that is toxic in the peel of carrots. I used to work with a plant breeder very early in my career who was breeding carrots, and I was interested to work with him because we were trying to breed carrots that could be resistant to nematodes. And he was explaining to me the nightmare that he had to show that his new carrot varieties did not have any more of that particular kind of molecule that is toxic in the peels of carrots than the old cultivars. And you have to do that if you introduce novel food, new cultivars, new everything. You need to show that. But not if you engineer plants containing new proteins. And if the government agencies and the biotech companies acknowledge that there are new proteins in the engineered crops,
yes,
then automatically those crops must be tested. That's the rule. That's the rule of the FDA. If you have new molecules in crop, new allergens, new toxic molecules, toxic proteins, they must be tested. So the government agencies are stuck. They cannot acknowledge the research done by independent researchers that there are new proteins in engineered crops, because otherwise they must be tested. It's the rule.
If somebody gave you the grant, Thierry, to test it, can you explain whether you're even allowed to test it? As I hear that these patented drugs, plants are having, the patent holder is having this intellectual property right, and you cannot test it without their permission. Is that true?
That is correct. That is correct. The technology is proprietary technology. It belongs to the biotech industry. They created the technology. It belongs to them. It is patented. You can only use them if they agree. You can only eat their product if they agree. It belongs to them. The seeds belong to them. You cannot use the seeds, the engineered seeds, without permission from the biotech companies. And you sign a technological agreement with them if you want to use their seeds. If you want to study the product, the engineered crops, you need their permission. Otherwise you will be sued. If you want to study their crop and you have their permission, you will get their permission only if you agree to show them your results first, before you publish. And I think there probably also is a requirement that you cannot publish without their permission.
And if your result is not flattering?
I'm sorry?
If you agree to all that and then you show them the result and the result is not flattering to the product, what happens? They will suppress its publishing.
I assume that. So that most of the research that is done that does not agree with the current dogma or the biotech industry or the government agencies, most of that research is done in other countries than Canada and the US. Mostly in Europe, some in India, Japan, Russia, and a few other places. I have more than a question.
Thierry, can you tell us what is this nitrogen fixing?
Nitrogen is in the air.
Yes.
With 80% of nitrogen in the atmosphere, and it's completely inert.
Yes.
Because there's two atoms tied by 3 bonds. It's very, very
strong.
Very, very strong. So we breathe it, and nothing
happens.
Nothing happens. It's completely inert. We take the oxygen from the atmosphere, but the nitrogen has no role at all. But the proteins contain nitrogen. The carbohydrates and the lipids contain carbon, hydrogen and oxygen. That's what the molecules are made from. The proteins and the nucleic acids have nitrogen in their molecules. And there's only one place that nitrogen can come from, the atmosphere. So the bacteria, 2 billion, 3 billion years ago, invented ways to fix nitrogen, to take the nitrogen from the atmosphere and put it in their body. they had to break the bond, the triple bond.
How did they do it, chemically speaking?
They do it with proteins. They have invented the proteins, enzymes,
They're strong enough to break.
to crack the nitrogen from the atmosphere. We humans have learned to do that 100 years ago. Using extreme pressure and temperature, we can crack the nitrogen from the atmosphere to make nitrogen fertilizer, to make nitrates and ammonia. We do that, for chemicals. The bacteria learn to do that at normal temperature and normal pressure using proteins. And the interesting thing is that every single molecule of protein on the planet comes from the atmosphere. The nitrogen can only come from the atmosphere.
So
Every single molecule of proteins from every living being on the planet and every single molecule of DNA and RNA, the nitrogen comes from the atmosphere,
amazing, huh?
from those bacteria. Thank you.
So how is it fixing? When you do nitrogen fixing, or they say do this or that is good for nitrogen fixing, what do they mean?
It means that there are certain bacteria that can do it, and no other organism on the planet can do that.
I see.
It's too complex. Those bacteria have invented the way to do it, and they're everywhere in the soil, but they are not photosynthetic, so they need to be fed.
Oh.
And so the way they work is that they are associated to plants. So there are certain plants that can host those particular bacteria. The biggest in the game is the family of the legumes, like the beans and the peas and the acacia and clover and alfalfa and all those other fixing nitrogen legumes. And so in the roots of those plants, the bacteria are in the roots of those plants, fixing the nitrogen from the air, giving the nitrogen to the plants, and in return they get fed by the plants, just like all the other bacteria. The plants are giving all their sugar to the bacteria.
Fantastic.